Hello everyone, in this video we're going to explore atomic number, mass number, isotopes, and how to calculate the average atomic mass of an element with multiple isotopes. As you may already know by reading the textbook and exploring the periodic table, the atomic number is the number of the protons of an atom. It's a fingerprint value, meaning no two elements have the same atomic number. In fact, the elements on the periodic table are put in order of increasing atomic number. We also have mass number, which is the sum of number of protons and number of neutrons of an atom. The reason it's called mass number because the nucleus, which is comprised of the neutrons and protons, accounts for most of the mass of the atom. After all, neutrons and protons are 10,000 times heavier than an electron. How to properly furnish these values around the atomic symbol? As you can see, the atomic number goes into the bottom right corner of the atomic symbol, and the mass number goes on top. These values could also be found on the periodic table. The number on top on a square in the periodic table is usually atomic number, and the mass numbers sometimes could be found at the bottom of the atomic box. Let's do a couple of examples where we figure out the number of electrons, protons, and neutrons from the atomic symbol. We have calcium first. Calcium has how many protons? Again, the atomic number goes in the lower left corner or the bottom left corner. 20 means 20 protons. How many neutrons do we have? If the mass number is the number of protons plus number of neutrons, and the atomic number is just the number of protons, the difference between the two would be the number of the neutrons. So 40 minus 20 is 20. How many electrons do we have? In a neutral atom, we have to have equal amount of protons and neutrons. Why? Because protons are positively charged and electrons are negatively charged with the same charge magnitude. Meaning charge size is the same, it's just the signs are the opposite. So if you have 20 protons, you have to have 20 electrons to counter those 20 protons charge and give you a neutral atom. Let's do another example. The element is neon. How many protons? Atomic number is 10. How many electrons? Same amount because neon is neutral. All right, atomic mass. What is the atomic mass? It is the mass of protons plus neutrons, 20. If you want to test yourself some more, you can do this question. The answer to this question could be found at the end of the slide deck, which is attached to this video. Let's discuss AMU, or the atomic mass unit. It's a contractual unit, and it's defined as 1/12 of the weight of a carbon-12 atom. So however much the 1/12 of a carbon atom weighs, that is 1 AMU, and then all the other atomic weights are measured comparatively to that value. But why do we say carbon-12? Are there carbon-13s and etc.? Yes, but the reason we have to specify carbon-12 because carbon has isotopes. Those are atoms of the same element that have the same atomic number, because after all, atomic number is a fingerprint value, but different number of protons, which means they have different mass numbers. So carbon-12, which is the majority of carbons out there, in fact, 98.93% of carbons are carbon-12, has 6 protons and 6 neutrons, but carbon-13 has 6 protons and 7 neutrons, and carbon-14, which is unstable, has 6 protons and 8 neutrons. So this means that out of the 1,000 random carbon atoms that you come across, 9,893 of them would be carbon-12, and 107 of them would be carbon-13s. And because carbon-14 is very, very negligibly present, we can just ignore its presence. So then what's the average mass of a carbon? You have to average this, right? How do you do it? What is the streamlined formula to calculate the average mass of an element with multiple isotopes? It's simple. It's the sum of the abundance multiplied by the mass of that particular isotope. So the mass of carbon-12 would be 98.93 over 100 times 12 plus 107 over 100 times 13. Again, abundance multiplied by mass. Let's articulate this in this next question. So we want the average atomic mass of oxygen. Oxygen has 3 isotopes. Oxygen 16, 17, and 18. Oxygen 16 would have 8 neutrons while having 6 protons. Oxygen 17 would have the same amount of protons but 7 neutrons. And O18 would have 10 neutrons. What is the formula for calculating the average atomic mass? The sum of abundance times the mass of isotope. So oxygen 16 has 99.76% abundance. That means 99.76 out of every 100 oxygens are oxygen 16. So mass, which is highlighted in yellow, multiplied by abundance, which is highlighted in blue. Same thing with 17 and same thing with 18. So you sum them up, you get the average mass at 16 AMU. If you want to test yourself some more, you can do the following question. The answer to this question could be found at the back of the slide deck.